All right, so let's take a look at this problem here. And they're asking in the very first problem, they're saying, hey, you're starting off with a certain amount of NO3 and NO, and they're asking, what can you say about the composition of the mixture in the vessel at equilibrium? In other words, how much are you going to have at equilibrium? And I want to point out this number right here. They tell us the K is 1.5 times 10 to the negative 12. Now, not negative 12, to the positive 12. That is an enormous number. And remember, in essence, all of our Ks, aren't they products over reactants? Now raised to the coefficient. So if I have a K value of 10 to the 12, that's going to mean that my reaction has gone crazy over this direction. So when I look at my choices here, I take a look and I say, well, there will be very little NO3 and NO. And the truth is, since the reaction is going almost entirely this direction, then there is going to be very little. Now, little NO2, no, everything's coming in this direction, and neither of the above is true. That's not true. So I'm going to put a little X right here because that's going to be our truth. Now, whenever we are dealing with changing an equation in some way, there's a couple of things we need to do. So if you take a look at this and you take a look at this right here, you'll notice that this reaction right here is just the reverse of this reaction. And so whenever we deal with the reverse of something, the equation that we need, or the way we solve it, is our new K is equal to 1 over the original K. So our reverse K is equal to 1 over our original K. So if we're doing the math on that, we literally are going to take our K value right here, which is 1.75 times 10 to the 12th, and we're going to go 1 over that. So we're going to go for our reverse K is going to be 1 over our 1.7 times 10 to the negative, or 10 I keep on saying 10 to the negative, but it's really 10 to the 12th, and that's going to equal a crazy small number, 5.71 times 10 to the negative 13, which kind of makes sense, because if the reaction is really wanting to go towards the products, then the reverse reaction is going to be very tiny. So I'm going to write 5.71 times 10 to the negative 13 in here. Now this one is very similar, except in this case, we're taking the original reaction and we're multiplying it by 3. Now, what do we do when we take an exponent and we raise something by a coefficient? I'm going to say that sentence again. If we have a K value and we multiply the equation by some number, in this case, the number we're multiplying by is 3, we raise the new K to that power. So what are we going to get when we do that? Well, let's take a look here. Our original K, the new K that we're looking for, and you can call it anything you want, this right here is going to become, our new K is going to be K, original one, to the third. So let's call this K3. We'll call this the reaction 2, reaction 3. Is going to be equal to K to the third. So if we do the math on this, literally we're going to take our original K, which is 1.7 times 10 to the negative, or 10 to the 12th, right? And we're going to raise it to the third power. Fun fact, if you ever have something raised to something else, you realize you can just multiply these two exponents. So what you're going to end up with is 5.36 times 10 to the 36, which I'm not going to bother rewriting right there for sake of time. But again, there's no units in this, and that's how you solve it. So just remember these two things. Whenever you are dealing with any sort of problem where they reverse the equation, you go 1 over. Anytime they multiply an equation by some variable, in this case they multiplied it by 3, you raise the new K to that power. Hopefully this helps.